So I will now step over to my second topic, that is the time validation. So time validation, that is handles a timestamp as a safe data. So why is timestamp safe data? So many sensor values provide information: how fast do we drive, what is current voltage or current performance load or anything else. Many of these sensor values are only useful with a valid timestamp. When was the data available? When was it valid? And if one value depends on several sources from a different ECU to get a combined picture of the environment, whatever this environment is, then this is only useful if these data that shall contribute to this common picture are taken at the same time, so or at least at a relatively same time, so that the time when the data were recorded do not differ too much from the time of the other recordings. So that makes clear that the time value itself, the timestamp itself, is a safety issue, and also it is an ASIL-related value, if it's an input to a safety-relevant computation. So looks easy, because with AUTOSAR we already have timing components in both adaptive and classic AUTOSAR, a synchronized time base. Why not use this? We want to use it, but that takes some effort. So the time that is the synchronized time that is already provided by synchronized time base that is available, but the timing, the timer to provide this value is usually in the QM section. So this timestamp is not regarded a safe timestamp. And to achieve a safe timestamp, we use the ASIL decomposition as it is defined in the ISO 262. So we distribute the task that we want to have a safe time, which is shall be ASIL B as defined in the concept, into two steps. So the first one is a QM step that is already available. That is a time provision STBM. That is a QM. As it's here described as QM of B because it's a derived topic. And we have the time validation. So the time validation shall check, that means compare the provided time with another time. And if the deviation is not too big, then it is considered a safe time. Of course, this second step must really be available in ASIL B and with a hardware timer, and that hardware timer is independent of the other source, the time provided by STBM. So what is a use case of this time validation? The one use case is the usual one, that is monitoring the synchronized time base. So that is simply supervision, let it progress from one sync point, and let the hardware timer run and find out if the time value that is based on this independent hardware timer, that it is really valid. Second, also provide a reliable status time information. That is, if I have a timestamp, give back information. Is this timestamp valid or not? And this is an add-on to the concept. So this is an idea that could be a further implementation. Use a third timestamp, so with an additional counter that also starts as a sync point and provides a third time value. So in this case, we would have 3 timestamps, and all the 3 timestamps compared to each other. And if the deviation is again not too large, is considered a safe timestamp, and otherwise not. But this is possible add-on mentioned in the concept. So we have with the concept the following constraints. We use only the Ethernet time sync. This is not defined for the older networks like CAN or FlexRay, but only to Ethernet. So we see here a limitation. Second limitation is also this concept aims to provide the time for a safe time only on highest level ASIL B, but not C or D. So C or D, if a computation with a timestamp of C or D is needed, this one is not applicable. And third, so an instance between the source of a time and the time consumer has to check the integrity of the time value that is provided by safe time validation. So we talk about the architecture of things. So the time validation is planned for classic AUTOSAR and adaptive AUTOSAR. In classic AUTOSAR, it is part of the current release. For adaptive AUTOSAR, not yet of this release. So the implementation goes that way, that the existing module, the Synchronized Time-Based Manager, STBM, is simply extended by the new functionality. So it means the new interface functions are simply added to the STBM module, and the existing interfaces that for the QM time base are not changed. So the functionality of the existing time provision is not touched. That is a great advantage. Interfaces that are not changed do not need changes in the using components. For the adaptive AUTOSAR, similar concept is applied, but in the adaptive AUTOSAR, we do not have the BSW modules with the functionality. In the adaptive AUTOSAR, we have a different architecture. It is built out of functional cluster, and the functional cluster that provides the time base is the cluster ARA T-Sync, and here we intend the same. The existing functions are not changed, remain the same, and the existing functionality, the additional functionality is implemented by additional interfaces. So for both platforms, that the classic AUTOSAR and the adaptive AUTOSAR, we have a fully backward compatible implementation. And no changes in interfaces means that the old ones who use the QM time can use it as it did before. So this great advantage of this feature is that we can have an extension on safety without touching the QM functionality. So it is fully backward compatible, and this is also one great advantage of this concept with the validation, and instead of implementing a provision of safe time base additionally. So that was my overview on a second concept, the time validation. I thank you very much for listening.